So we've learned our 6 basic rules, and these 6 basic rules we have to have memorized. The rules are that the integral of a constant dx is equal to that constant times x plus c. The second rule we learned is that the integral of x to the n dx was equal to 1 over n plus 1 times x to the n plus 1 plus c. The third one is constant multipliers, so the constant times f of x dx multiply along is equal to the c times the integral of f of x dx. Number 4, we learned that we can integrate a term at a time. So we are allowed to find the integral of a term at a time. So this is equal to the integral of f of x dx plus or minus the integral of g of x dx. Number 5 is always going to be our favorite. The integral of e to the x dx is e to the x plus c. And then finally, the integral of 1 over x dx is going to equal the natural log of the absolute value of x plus c. So we have to have all 6 of these memorized because we're going to get to more complicated ones in our next section. But those are the 6 that we know, and then we're going to use those 6 to answer questions 13 through 18. So let's find each indefinite integral. So I have the indefinite integral of the square root of x plus 3 over x minus 2e to the x. So let's go ahead and rewrite this first. Well, remember, the square root is always going to be x to the 1/2 power. Now 3 over x, well, 3 is that constant multiplier because I know what 1 over x dx is. So I'm just going to go ahead and split it up as plus 3 times 1 over x minus 2e to the x dx. And now I know that I can take the integral of a term at a time. So let's go ahead and start there. So this is going to be 1 over, because here my n is equal to 1/2. So on a calculator, if we need to, but 1/2 plus 1 is 3/2. So 1 over 3/2, x to the 3/2, plus 3 is a constant multiplier, it multiplies along. 3, the integral of 1 over x is the natural log of the absolute value of x, minus 2 is a constant multiplier, it multiplies along, 2, and the integral of e to the x is e to the x plus c. So we just look at these rules and use these rules when we're finding that indefinite integral. The last thing we can do here, again, if you do it on a calculator, 1 over 3/2 is going to end up being 2/3. So we'll just write that as 2/3 x to the 3/2 plus 3 times the natural log of the absolute value of x minus 2 e to the x plus c. And like I said before, you don't write the plus c for each one of these because c is just c, so c plus c plus c is just going to be c. So only write your plus c at the very end, but make sure that you write your plus c because if you don't, then the answer is incorrect. So we need that constant of integration. Anytime we're dealing with the indefinite integral, we need the constant of integration to show that it's a family of functions that is our answer. So let's look at number 14. So number 14, we have the integral of t cubed plus 3 over t squared. Well, again, I've not taught you anything about division, so with these problems, we know we rewrite them. So we could rewrite this as the integral of t cubed over t squared plus 3 over t squared dt. Well, t cubed over t squared is the same as the integral of t. And then 3 over t squared, be really careful. A lot of students think 3 over t squared is the same thing as 1 over x. That's not the same thing. When this exponent is not a 1, it is not the same thing. For these, we want to use our general power rule, so you have to rewrite it as a power. Because, just note, 3 over t squared doesn't equal, nor will it ever equal 3 over t. This would give you a natural log, this will not. So be really, really, really careful there. Well then, both of these are just using my general power rule. For the first one, the exponent on t is 1, which means my n is equal to 1. Therefore, I'm looking at 1 over 2 t squared plus 3 is a constant multiplier. It multiplies along. Here my n is equal to -2, so times 1 over -1. This is t to the negative first plus c. And if I clean that up, I end up with the answer of 1/2 t squared. 3 times 1 over negative 1 is just going to be minus 3. T to the negative first plus c. Number 15, u to the negative third times 10 minus u to the third plus u to the second. Well, again, with this, we have not learned anything about multiplication. So what we need to do is we need to rewrite this first. So in order to rewrite this, what we would do is here, we would distribute u to the negative third to all three of those terms. So we're going to distribute u to the negative third to all three terms. Therefore, we get the integral of 10 u to the negative third. Well, u to the negative third times u to the third, when our bases are the same, we add our exponents. So we're looking at minus u to the 0 power, and I'll fix that in a second. Plus, again, when your bases are the same, you add your exponents. So negative 3 plus 2, we're looking at u to the negative first du. So u to the negative first, I'm going to scroll and come right back up to that. Remember, u to the negative first is this 1 over x. So let's go ahead and rewrite the whole entire thing before we integrate. So this is the integral of 10 u to the negative third. Anything to the 0 power other than 0 is 1. And then I'm going to write u to the negative first as 1 over u to remind me that I'm going to be using the natural log of the absolute value of u to integrate that. So now let's find the indefinite integral. So here, 10 is a constant multiplier. It multiplies along. N here is equal to negative 3. So times 1 over negative 2, u to the negative second. The integral of 1, well, 1's a number, so that's going to be minus 1 times u. Plus, the integral of 1 over u is the natural log of the absolute value of u plus c. Moving over here, well, 10 times negative 1/2 is going to end up being just negative 5, u to the negative second. I don't need the 1 coefficient there, so I'm just going to write minus u plus the natural log of the absolute value of u plus c. Couple of things I just want to state here before we move on is make sure that when you're doing all these problems, there's a lot of practice in them. I put a lot of problems in them. Practice more if you need to. You want to get comfortable with all these rules before we move on to section 5.2 because the rules will get more complicated in section 5.2. But make sure that you're writing your plus c's, because if you don't have your plus c, your answer is incorrect with the indefinite integral. And then make sure when you find the integral of that 1 over u du that you put those absolute value bars around your u. So a lot of times students forget to put absolute values here and they forget your plus c. Both of those would result with incorrect answers. All right, let's move on. So we're going to now look for a particular antiderivative of a derivative. So how do you find a particular antiderivative? Well, if you're given a point on the original graph, so an initial value, you can actually find the exact value of c for that antiderivative. You can actually solve for c and find the exact or particular antiderivative. So we're going to do that for the next 3 examples. So let's find the particular antiderivative of each derivative that satisfies the given condition. So for us, our given condition here is f of 2 is equal to 4. So I'm given that the derivative f prime of x is equal to 3x squared minus 6x. So in order to find f of x, or the original, I have to find the antiderivative. So I need to integrate. Well, I'm just going to use those rules that I know from before. Well, 3 is a constant multiplier. It multiplies along. This is just the power rule. My n is equal to 2, so it's going to be times 1 over 3 x to the third minus 6 is a constant multiplier. It multiplies along. Here my n is equal to 1, because remember, if there's no exponent, it's an implied 1. So I have times 1 over 2 x squared, and then plus my constant of integration. So if I clean this up, I get that little f of x is equal to, these 3's cancel, x cubed minus, well, 6 times a half is 3x squared plus c. So now I'm asked to find the particular antiderivative, which means that, hey, I'm given this condition that when x is 2, y is 4, well, that's enough information to solve for c. So again, it's telling me when x is 2, so that means everywhere there's an x, instead of writing x, I'm going to write a 2. And my y, or my f of x, is equal to 4. So if I look at this, I actually have enough information here to solve for C. So if I work this problem out, I get 4 is equal to 8 minus 3 times 2 squared. Well, 2 squared is 4, so 3 times 4 is 12 plus C. So 4 is equal to here, 8 minus 12 is a negative 4 plus C. If I add 4 to both sides, I end up with 8 is equal to C. Therefore, these three little dots means therefore, my particular antiderivative f of x is going to equal x cubed minus 3x squared. Instead of plus c, I'm going to write plus 8. So the particular antiderivative that satisfies that given condition of f of 2 is equal to 4 is going to be x cubed minus 3x squared plus 8. Let's do this again for example 17. Well, example 17 says that dy dx is equal to e to the x minus 2x. And my initial condition is that y of 0 is equal to 2. So the first thing I need to do is find the antiderivative. So I'm going to say that y is going to equal, right? I need to find the antiderivative here. Well, the integral of e to the x is e to the x minus 2 is a constant multiplier. It multiplies along. Here I'm going to use the power rule. Remember, the exponent is 1 if there's no exponent. So my n is equal to 1. So this is times 1 over 2 x to the second power plus c. Let's clean this up before we solve for c. So we get y is equal to e to the x. Here my 2's cancel. So it's just minus x squared plus c. So now I'm going to use my initial condition to solve for c. So I'm told when my x's are 0, my y is 2. So my y would be 2, and my x's would be 0. And now I need to find out what c is. So working this problem out, 2 would equal, well, e to the 0 is equal to 1 minus, well, 0 squared is just 0 plus c. So then I get 2 is equal to 1 plus c. Subtracting 1 to solve for c, and I get 1 is equal to c. Therefore, the particular antiderivative would be y is equal to e to the x minus x squared, and instead of my plus c, I would write plus 1. So the particular antiderivative is e to the x minus x squared plus 1. Let's look at number 18. The directions for number 18 change a little. It says to find the equation of the curve that passes through the point 1, 2 if the slope is given by dy dx is equal to x squared minus 2x plus 3 for each x. Now, the directions sound different, but this is the same thing as numbers 16 and 17. You're finding a particular antiderivative for this function, given the initial condition of u goes through the point 1, 2. So the first thing to do is start by finding the antiderivative. So we say y would equal, well, here my n is equal to 2, so this is going to be 1 over 3 x cubed minus 2 is a constant multiplier, it multiplies along. Here my exponent is 1, because remember, if there's no exponent, it's the implied 1. So that's times 1 over 2 x squared plus, well, 3 is just a constant, so remember the integral of a constant is that constant times x. And don't forget your plus c. So clean this up before we solve for c. So y would equal 1/3 x cubed. Here my 2's cancel, so it's just minus x squared plus 3x plus c. So now I use that initial condition that says when my x's are equal to 1, my y is 2. So 2 is going to equal 1/3 times 1 cubed minus 1 squared plus 3 times 1 plus c. And that's enough information for us to solve for c. So I end up here with 2 is equal to, well, 1/3 times 1 cubed is just 1/3 minus 1 plus 3 plus c. So then I get 2 is equal to, well, 1/3 minus 1 plus 3. We could always do that on a calculator if you need to. So again, it's just going to be 1/3 minus 1 plus 3, and we end up with 2 1/3, which if we make that into a fraction is 7/3. So we end up with 2 is equal to 7/3 plus c. If I subtract 7/3 from both sides, we'd have 2 minus 7/3, and then again you make that into a fraction and you get -1/3. So you end up with -1/3 is equal to c. Therefore, that particular antiderivative here, right, the equation of the curve that passes through that point would be y is equal to 1/3 x cubed minus x squared plus 3x minus 1/3. That's it for section 5.1.